Hello and welcome to this presentation about vacuum solutions for the future mobile vacuum industry. No pollution, no noise, just vacuum, and why use the liquid ring pumps for vacuum trucks. I'm Morten and I'm responsible for sales here in Samsung Pumps. Along with me is Kjell.
Hi.
Kjell is in charge of our marketing. During the next half hour, we'll take you through the basic introduction to liquid ring vacuum pumps. This is the agenda for the day. We'll go through a brief introduction. We'll explore the specific requirements of vacuum truck operations, then discuss the advantages of liquid ring vacuum pumps. We'll delve into the design, operation of the pumps. We'll discuss the different types of pumps available in the market, also which key components goes into the vacuum pumps. Then we'll go to right sizing and configuration of vacuum systems. Then, before we do the wrap up, we'll go through various applications of liquid ring vacuum pumps and a few case studies that demonstrates the effectiveness of liquid ring vacuum pumps.
Well, enough of the warming up. Let's get started. And we will start by putting a few more words on what this is going to be about. What is a liquid ring pump? The words in themselves give it away. It is a pump that works by means of a liquid ring. But how does it actually work? Well, here's a cut through of the pump, seen from the shaft end. The pump is filled up with liquid, and that's typically water, and it's filled up to approximately half of the housing volume. The rotor starts spinning, and the centrifugal force pushes the liquid towards the housing wall. And you get the liquid ring here. The liquid ring and the rotor cells create a piston pump effect, and you get the suction and pressure effect. We'll get more into these details later on. A liquid ring pump is a vacuum source being used in many industries, both for stationary and mobile applications. What are vacuum trucks being used for? Well, trying to unfold our session title on using liquid ring pumps for mobile applications, let's have a look at vacuum trucks in general. The vacuum pumps are a crucial component for the vacuum trucks. The vacuum trucks are helping individual households, for instance, emptying their septic tanks, keeping underground infrastructure clean in cities, and for industries, the vacuum trucks handle their wet waste. In the world of liquid ring vacuum pumps, we see them being used for a lot of jobs, taking care of liquids and fluids, taking care of sludge and sewage, and also working with debris and excavation. But what kind of requirements are in play in relation to vacuum truck operations? Well, Morten will explore these in our next session.
Now we will unfold on the three main areas as Kjell mentioned in the previous section. Starting with the moving liquids and fluids. As you can see from the screen, this is a spill containment action where the liquid ring vacuum pump excels by its ability to create deep vacuum and also the ability to run at different speeds so you can control the flow to suit the specific task. With chemical and maybe even hazardous spills, any vapor or carryover from the vacuum tank into the pump system will be absorbed in the surface water of the pump and to a certain extent neutralized by this scrubbing effect of the liquid ring vacuum pump. Then the now contaminated water can be safely drained and correctly handled after the end of the operation. Furthermore, if it is a chemical spill, it's very smart to use the liquid ring vacuum pump because they can be classified as explosion-proof equipment due to its design with no mechanical contact and very limited heat generation. Moving on to the sewer and industrial cleaning. Again, as mentioned with the spill containment action from the previous slide, any potential carryover is absorbed in the surface water and contained. Furthermore, there are no tight spaces within a liquid ring vacuum pump, so organic materials or finer materials can easily pass through the pump without harming the pump or limiting its performance. Going into the industrial cleaning segment, again, the no mechanical contact that leads to the explosion-proof certification will make the pump very usable in this segment, and especially if talking about for the VOC industry, meaning for the oil and energy segments, also for the sand cleaning, it could be polluted mud. The pump excels and will not be damaged if any potential carryover enters the pump. The liquid ring vacuum pump technology is also used for cutting through the subterranean in the oil industry. Moving on to the third area, which was excavation. As presented in this picture, it is clearly a backhoe laying down a pipe, which has nothing to do with liquid ring vacuum pump, but the liquid ring vacuum pump is very usable for the potholing, or call it daylighting, where it is determined where to dig and lay down the piping. Again, the advantages are that if there are any smaller particles or sand entering the pump system, it will not harm the pump. Now moving on to the next segment where Kjell will talk about the advantages of the liquid ring vacuum pumps.
Talk about the advantages, a good starting point is to understand the operating principle. Actually, it's key to the advantages and benefits. How it works. The operating principle, well, as we saw before, we have filled the pump halfway with the liquid, and we have spun the rotor so that it creates the vacuum ring as we see it here. Holes in the flow plate, as you see here in the background, work as inlet and outlet ports for the air. The liquid forms a barrier and creates small buckets for air. As the air spins round, the continuous increase in volume creates the suction. And on the other hand, as the volume starts decreasing, air is pushed out of the pump and creates pressure. And again, please note that there's no physical contact with the rotor and the housing wall. The liquid ring itself absorbs vibrations and noise coming from the pumping process. So, no need for oil to run the pump, as the water works as the sealant. And what is the benefits coming out of this? Well, no pollution, and air pollution especially. It's about air quality, and that is an ever-increasing focus point. So cutting down on pollution is crucial. Polluted air around the world leads to untimely deaths and huge costs due to related diseases, as well as reduced quality of life. Liquid ring pumps help in this, as they don't use oil as a sealant, meaning no oil emissions and less pollution. So all that remains is just clean exhaust. A second benefit is the very low noise level. Noise is about sound pressure levels. These levels are measured on a logarithmic scale and expressed in decibels. So a 3 decibel increase is actually a doubling of the noise level. Measurements on the liquid ring pumps are as low as 63 decibel. Sound levels at or below 70 decibels are considered safe for our hearing. Other vacuum pump technologies have other sound levels. And then, remembering that 3 decibel is a doubling, we see some interesting figures here. Avoidance or reduction of noise is crucial for operator safety and health. In a vacuum truck, multiple noise sources contribute to the overall sound pressure. So therefore, reducing each sound source decreases the total noise. So what are the major advantages from a liquid ring pump? Well, as said, no pollution, no noise, just vacuum, letting the operators do a good, efficient job on site in a safe working environment. But after this, let us take a deeper dive into the features that bring these advantages. Getting into the design and operation, let us look at some of the features. Features for both the liquid ring pump and a complete vacuum pump system with a liquid ring pump. As you see here, it's a simple design, few components. So this limited number of components gives the simplicity, which will also give increased durability. As little as possible and as much as needed. The simple design leads to a robust construction withstanding very tough operating conditions. But we'll get back to the operating conditions in a bit later, and also we will have a closer look at the components later. A liquid ring pump system has a simple operation and layout. Let's do a build-up of the system to understand more. So we will take this slide apart and do a build-up component by component. So we will start with the tank here on the right and 4 lengths of pipe. Position 1 is the liquid ring pump, and the rule of thumb is to place the liquid ring pump as low as possible. A low placed pump opens more options for placing the water tank and enables the water to flow to the pump by gravity. Position 2 is the non-return valve. It is important to install a non-return valve on the pressure side of the pump. In a situation where the slurry tank is evacuated and the liquid ring pump stops rotating, the non-return valve will prevent the vacuum from the slurry tank to empty the pump and the water tank. Position 3, the four-way valve. A four-way valve is used to change from suction to pressure, and this enables the operator to fill and to empty the slurry tank. Position 4, the vacuum control valve. This valve is designed to control the vacuum level and avoid cavitation in the pump. Position number 5 is the stop valve. This valve is to stop the flow of water into the pump to secure the pump from being flooded. Position 6, here we have the water separator and the water tank. The water tank can be built into the main tank as seen here, but it can also be placed outside the main tank. Here you see the water tank also with a water separator built in, and the water separator separates the water and air. Water will be kept in the water tank and the air leaving through the exhaust pipe. Position number 7 is the primary shut-off. A primary shut-off is equipped with an overflow system which prevents the suctioned material, liquids or similar from entering the vacuum line when the maximum level inside the tank is reached. However, it happens that particles are carried over through the shut-off, and a liquid ring pump will handle such overflows. So we left with the airflow here, and when the pump starts, you will see from the overflow valve, you see the arrows here that the air is moving from the tank to the suction side of the pump. The discharge from the pump goes into the water separator, Here the water particles from the liquid ring are caught and recycled to the water tank. Air is then finally being discharged through the exhaust pipe. And that is how the system works. So, design and operation for a complete liquid ring vacuum pump system sums up being compact and lightweight. Limiting the weight and space requirements for the internal piping and pump system will also allow for more space for the main tank, meaning more jobs before the tank is full. So, as we say, you just add water and go. But as mentioned earlier, there are also other vacuum pumps which are doing a good job out there. So, Morten, could you take us through a quick discussion on some of the other pump types?
In this section, we will talk about alternative technologies and also the liquid ring vacuum pump. We're starting off with the rotary vane pump, which is a common pump design for various reasons. Some of the reasons are that it's a cost-effective design and a straightforward installation. However, it requires oil for lubrication to limit the wear and tear that comes from the mechanical contact within the pump. Some of this oil will be discharged out into the surroundings from the discharge side of the pump. For that reason, it is important to have filters on that discharge side to prevent the pollution going into the air and on the ground from where the job with the vacuum pump is being performed. Furthermore, fluid and debris is harmful to the rotary vane pump if it enters the pump. For that reason, it is crucial to protect the suction side with filter tanks, cyclones, and additional filters to avoid the pump to break down. Furthermore, from the mechanical contact within the pump, a noise level is created which is beyond what is recommendable for operator safety. So, in addition to the straightforward and cheap design, you need additional filters both on the suction and discharge side as well as a silencer. Moving on to a blower. Blower is also a common pump design which typically has a high airflow and is also a pretty straightforward installation in its basics. It does not require oil for lubrication because there are no mechanical contact. However, it is a very tight space between the lobes, so it creates a very high noise level. So silencing is crucial on a blower. Furthermore, due to this tight space between the lobes, filters is crucial to protect the suction side. So again, cyclone, filter tanks, and filters must be installed when using a blower. And add to that the high noise level, as mentioned previously, which also requires a silencer. Then we go to liquid ring vacuum pump. Liquid ring vacuum pumps are much less sensitive on the suction side than the other types mentioned, and the pump does not need comprehensive filtering installed. It is a reliable and durable design, which is less likely to be damaged by sand or organic fragments entering the pump. It does require a water tank and some piping. However, the pump is very silent and does not require any silencing at all. Now we'll go through the key components that make up the liquid ring vacuum pumps. One of the key components is the rotor. It is purpose designed for high vacuum and high durability. The second key component are the flow plates, which in a brass material can be classified as explosion-proof equipment. The flow plates are designed to determine which side is the suction side and which side is the discharge side of the pump. The third key component is water. We usually say just add water and go. It is not far from the truth. Water is a key component, it is easy accessible, and it is a very cost-effective resource. Water also absorbs the heat from the pumping process. It also dampens the noise from the pump, so it is very silent. It also contains potential emissions from the product being pumped into the vacuum tank. And the water is also containing potential emissions from vapors and overspills from the main tank. Furthermore, there are other but very few components within a liquid ring vacuum pump. It is a simple construction with no mechanical contact and only a few moving parts. It is easy to maintain and service. Repair and maintenance can be carried out locally and does not require special tools or special skills. Let's talk right sizing and configuration of a vacuum pump system. This is important because a vacuum pump system is oftenly a crucial and costly part of a vacuum truck investment. We believe that both the upfront investment and the daily operation cost can be reduced without compromising the overall performance and efficiency of the vacuum truck. That is because the pump performance is dependent on system design, and the investment and daily operation cost is a direct consequence of the system design. So selecting the correct pump to the system will often reduce both the installation cost and the operating cost. Therefore, we say do not look at the pump performance alone. Instead, consider the whole system performance, starting with the hose end flow. So, why is hose end flow important? To understand this, we need to talk about the law of the physics. At 10 meters per second or 32 feet per second, all powders will fly. At 25 meters per second or 83 feet per second, all fluids will move in a suction pipe. And exceeding 35 meters per second or 115 feet per second, even solid topics will move. These values are given no matter what diameter of the suction hose is present on the truck. So hose size matters. There's only so much space available. So using the right size of pump is important. This sketch underlines why it is so important to discuss system performance and hose end flow. You can see here there's quite a distance from the suction hose, which is placed on the back of the truck, all the way through the vacuum tank, maybe through some filters and some valves, all the way up to the vacuum pump, which is shown as the circle right behind the truck cabin. So discussing the hose end flow is important because that is the real world performance. This is what you get from your truck. If you imagine that you already have a vacuum pump system meeting the air speeds mentioned in the previous slides, then you're already at the right size. Now one could think, let's notch up the pump size a bit, but what happens? Nothing really. The flow will not increase because you're already at a maximum pressure in the system. So installing a larger pump will only increase the purchase cost, installation cost, operation and maintenance cost. All of them will just drain the owners and operators' pockets. So starting with the hose inflow, and from there look into the system performance to choose the right size of pump.
So now we've come to the various applications for liquid ring vacuum pumps. We'll be catching up on our initial slide on what vacuum trucks are and our run through of the specific requirements of vacuum truck operations. So let's have a look at some of the many applications where liquid ring vacuum pumps come into play. Fluid handling trucks, well, they are useful for managing liquid and semi-solid waste. They are essential for cleaning out different liquid waste systems and for environmental cleanup efforts. These trucks are designed to manage and dispose of waste with a high water content, and also cleaning and maintaining vessels, pits, tanks, and silos, collecting of various kinds of waste, for instance, grease traps, oily water, sludge, contaminated water, stormwater, and drill water. This is where fluid handling trucks come into play. Then we also have the conventional trucks. These trucks handle a broad range of uses. This is actually, you could say, the Swiss Army knife of vacuum trucks. From managing dry bulk materials to handling hazardous waste, they are designed for versatility across multiple industries. In this group of applications for liquid ring vacuum pumps, you will also find the industrial vacuum trucks, which are built for handling hazardous materials, waste removal from industrial facilities, and even managing materials in mining operations. Also, a group of pneumatic vacuum trucks will be found here, which are often used in powder terminals and foundries and other locations that handle dry bulk materials. Pneumatic vacuum trucks are good at suctioning, holding, and discharging fine particles. A third group of conventional trucks is the combination vacuum trucks. These trucks combine high pressure water jetting and a high powered vacuum, making them ultra versatile. They are perfect for cleaning sewer lines, catch basins, and storm drains, or performing general street flushing. The last group are the excavation trucks. These trucks are specifically used for digging through the ground while ensuring minimum damage to the surrounding areas, making them very useful in sensitive excavation tasks. Excavation trucks excel in specialized applications such as daylighting or potholing and slot trenching. Hydro excavation trucks are also part of this category. They use high pressure water and a vacuum. These trucks apply the non-destructive method of excavation, making them suitable for utility construction and engineering usage where underground utilities might be present, such as cables, pipes, and other underground infrastructure elements. Before wrapping up, we would like to present two cases very briefly. The first case is our no pollution case. The Public Works Department complained about sewage trucks causing spills and oil films in the city centers, damaging asphalt, concrete, and buildings. These spills pose safety risks for general traffic and pedestrians. Vacuum truck operators were also working in a health hazardous working environment. So, to safeguard public interests and operators' health, the sewage company decided to install liquid ring vacuum pumps in their fleet. This resulting in a continued business with the Public Works Department, securing future contracts, and also significantly improving working conditions for the vacuum truck operators, making them stay on with the company. Our second case is about noise. There was increasing complaints from residents and passers-by pinpointing the disruptive noise from vacuum trucks, particularly during nighttime operations. For a German fleet owner, resolving this was critical, especially as environmental regulations limited opportunities and impacted fleet utilization. So, in collaboration with the vacuum truck provider, the fleet owner sought alternative vacuum systems to rebuild his fleet. The need to cut down harmful noises prompted a closer examination of liquid ring technology. The decision was made to switch his fleet's vacuum source to liquid ring pumps. The transition to liquid ring technology restores the fleet owner's ability to secure more contracts and increased profits. Moreover, residents, passers-by, and even the fleet's operators are all now appreciating the newfound quiet. So, with this, we will get into our wrap-up of this presentation. We looked at the requirements. We explored the specific requirements of vacuum truck operations. We examined the various applications of liquid ring vacuum pumps. We discussed the advantages of liquid ring vacuum pumps. And we also looked into the design and operations of liquid ring vacuum pumps.
So why use the liquid ring vacuum pumps? Besides equal or better performance to existing technologies, we're starting from left saying there's very low noise, it is environmental friendly, it requires minimal maintenance and thereby also very low cost to run. It provides a much safe work environment and requires no additional filters to protect or clean the discharge side of the pump. Now we're at the end of the presentation and we want to leave you with an open invitation. Please reach out if you have any question or comment. Find our contact details on our website samson/pumps.com or look at LinkedIn. Thank you so much for participating in this webinar.